welcome to Chore Chapters, because everyday tasks need good company. I'm Leo, and with me as always, we have got Luna.
Hey everyone, I hope you're all doing well. Today we've got a thrilling and interesting story lined up, so grab your headphones and let's dive straight into the story.
The power of DNA, it's really something else, isn't it? It's completely changed how we think about identity, about family.
Oh, absolutely.
And, of course, how we solve crimes.
Yeah.
And now, well, that power is being used in some really surprising ways. So today we're doing a deep dive into something called forensic genetic genealogy. You might see it called FGG.
Right, FGG.
We've pulled together some really fascinating stuff here, looking at it from the legal side, the science side. Basically, trying to get our heads around what FGG really is. Our mission, really, is to unpack this powerful investigative tool. We want to look at how it works, sure, but also the big questions, the concerns that come along with it. Think of it as your shortcut to understanding something that's pretty complex and honestly changing all the time. When you think about DNA forensics, it just feels like it's constantly leaping forward, right? We've come such a long way. How did we even start using genetics in investigations? What were those early days like?
You're right. It's a world away from where we started. In the very beginning, we were working with something called mini satellites. VNTRs is the other name.
VNTRs, okay.
Think of them as sort of unique genetic fingerprints for each person. A really big moment was when Professor Jeffries used this technique, this DNA fingerprinting. He used it to confirm a mother-son relationship. It was in a Ghana immigration dispute that was huge, proving kinship with DNA for the first time.
Wow.
And then, of course, the famous Colin Pitchfork case. That's where DNA profiling didn't just link two murders to one guy. But, and this is crucial, it cleared an initial suspect. First-time DNA actually exonerated someone.
That's incredible. But I imagine those early methods weren't perfect.
No, not at all. While they were groundbreaking, they had real limitations. Imagine trying to find, specific large markers spread far apart in the genome. You needed pretty large, good quality DNA samples. And that's just not always what you find at a crime scene, right? Things degrade or there isn't much to begin with.
Makes sense.
Exactly. So that's why the field moved towards much smaller, more numerous genetic markers, things like microsatellites, STRs, and single nucleotide polymorphisms, SNPs, and even things called insertion deletions, INDLs. The key thing is they're all much smaller.
So easier to find even if the sample isn't great.
Precisely. It means we can work with tiny amounts of DNA or DNA that's degraded. That was a total game changer for forensics.
Okay, so if we've got these super sensitive new DNA markers, how does forensic genetic genealogy, FGG, actually use this information? Because I always pictured it finding an exact match in a database.
Yeah, and that's the really crucial difference with FGG. It's this emerging practice that pulls together DNA analysis, these huge genealogical databases, and statistical methods. Its main goal is identifying people, usually suspects or victims in crimes, but not typically through a direct match. It does it by tracing their relatives.
Relatives.
Yeah,
Wow.
yeah. And it's also proving really useful for, kinship determination in adoption cases or helping reunite families.
So wait, hang on. This isn't the database hit we see on TV shows. It's more like building a family tree from someone who might be, a second cousin, a third cousin. That's a huge leap. What kind of genetic information are we even talking about to make that possible?
Exactly. That's often the aha moment. FGG mainly uses SNP profiles, those single nucleotide polymorphisms. They're different from the STR profiles you find in, say, CODIS, the criminal justice database.
Okay.
With SNPs, you don't need that perfect match. Even pretty distant matches are incredibly useful. So for instance, a 50% match, that's a parent or a sibling. A 12.5% match usually points towards a first cousin. And even a third cousin match, we're talking less than 1% shared DNA sometimes. That can still provide a vital lead.
Less than 1%. That's amazing.
It is. And think about the databases. Something like GED Match, which our sources mention, has maybe 1.5 million profiles. Sounds like a lot, right?
Yeah.
But compare that to, say, the 330 million people in the U.S. alone. So finding a perfect match to your unknown suspect in these consumer databases is actually pretty rare. But finding those distant relatives, that's the absolute key to how FGG works. And here's another really vital point. CODIS contains profiles from people connected to the criminal justice system. FGG uses profiles uploaded to open databases by regular consumers.
Right. People looking for family history or health info.
Exactly. They're doing it for personal reasons, finding relatives, learning about ancestry, maybe health traits. Their intent is completely different. They didn't sign up thinking they'd be helping solve crimes.
Okay, let's really unpack this then. Given all that, how does law enforcement actually do this? What are the practical steps? They get a DNA sample from a crime scene, then what?
Right. It's a very methodical, multi-step process, almost like a genetic detective story. First, they need to develop a profile. So investigators take that DNA from the evidence, could be from the crime scene, could be from remains. They check its quality, quantity, and then they create a SMP profile from it. And it's crucial they have the original biological evidence. You can't just convert an old STR profile into a SMP profile. You need the source material.
Got it. Step 1, get the SMP profile. What's next?
Step 2, search open source genetic databases. The police, or sometimes specialized contractors they hire, upload that SNT profile they just created. They upload it to platforms like GDmatch or others that allow law enforcement searches under specific conditions. The system then flags possible relatives, however distant they might be. And algorithms help estimate the likely degree of kinship, how closely related they probably are.
Okay, so they get a list of potential relatives. Then what? Do they just start calling people?
No, not quite. Step 3 is where traditional detective work really meets genetics. They create family trees for potential relatives. This usually involves bringing in a professional genealogist. Their job is to meticulously build out family trees for those individuals the database flagged as relatives of the unknown person.
Wow, so it's not just computers. There's actual, old school genealogy involved.
Absolutely. That deep genealogical research is critical, which leads to step 4. They work with a genealogist to identify possible candidates. They start narrowing down the list of potential subjects, focusing on branches of the family tree that make sense based on the estimated degree of kinship, that percentage match we talked about.
Okay, narrowing it down.
Then, step 5, they consider other evidence. This is crucial. Investigators integrate everything else they know about the suspect eyewitness descriptions, maybe surveillance footage, timeline, geographic possibilities. They use all that to start ruling people in or out from the list generated by the genealogy.
So the DNA is just one piece of the puzzle.
Exactly. Which flows into step 6, further investigation. This is standard police work. Using traditional techniques to research the remaining potential suspects, talking to family or associates, maybe checking work records, arrest histories, that kind of thing. And really importantly, trying to rule people out. They have to document this part really carefully to avoid jumping to conclusions or, confirmation bias.
Makes sense. Got to be thorough.
Absolutely. And then finally, step 7, confirm through further testing. If a really strong, viable suspect emerges from all that work, law enforcement works with a prosecutor to legally obtain a new DNA sample directly from that suspect. They have to be really careful here about Fourth Amendment rights, search warrants, etc. An arrest is typically only made if this second independent DNA test confirms a match and all the other investigation lines up.
Okay, that's a much more involved process than I think most people realize. Which brings us to the tricky part, right?
Yeah.
Because FGG sounds incredibly powerful and it solves some amazing cold cases.
Mm-hmm.
But it also brings up some big challenges, some serious concerns that need careful handling. It's not just a magic bullet, is it?
Not at all. You're absolutely right. The concerns around FGG, they generally fall into 3 main buckets: efficiency, accuracy, and the big one, privacy.
Okay, let's take those one by one. Efficiency. I thought this was supposed to be faster.
Well, faster than maybe never solving it, but it's definitely not a quick fix. FGG demands quite a bit of time and money. You've got the specialized SMP profiling, the sample processing, the complex data analysis, and then all that traditional genealogy work we talked about, which can be very labor-intensive. And another point on efficiency, genealogical records are much easier to trace in some places, like the US and a lot of Europe. But in other parts of the world, or for certain cultural groups, the records might be sparse or just not there. That makes building those family trees incredibly difficult, sometimes impossible, and definitely more expensive.
So it's not equally effective everywhere or for everyone.
Exactly. So agencies really have to weigh whether a particular case is a good candidate for FGG, given the resources it demands.
Okay, efficiency makes sense. What about accuracy? We often hear DNA doesn't lie, so isn't FGG inherently accurate?
That's a common assumption, but it's more nuanced. While the DNA testing itself, done properly in a good lab, is highly precise, the overall investigation needs extreme diligence to be truly accurate. Think about the sample itself. Was it pure? Or was it mixed with other DNA, maybe the victim's? Can they reliably separate those out?
Good point.
Has time or environmental factors degraded the DNA? Is there even enough genetic material left for the initial SNT profile and potentially later confirmatory tests? And maybe the most fundamental question: does this specific DNA sample actually have probative value? Meaning, can we be sure it was left by the perpetrator and not just through some random innocent transfer?
Great, the touch DNA issue.
Yeah, precisely. And beyond the sample, you have other factors. How reputable is the lab doing the testing? How skilled and unbiased are the forensic genealogists and the traditional genealogists involved? And this loops back to what we said before, the vital role of traditional police work. It's essential for eliminating potential suspects, not just pointing fingers, and for corroborating any lead FGG generates. Can't stress this enough. An arrest should never, ever be based solely on an FGG result. It's a powerful investigative lead, but it's not proof on its own.
Okay, that's a critical clarification. Efficiency, accuracy, and now the big one, privacy. This feels like the elephant in the room. We're talking about using databases full of DNA from ordinary people who are just curious about their ancestors. What are the privacy implications here?
Yeah, privacy is definitely the most complex and hotly debated aspect of FGG. There are really three key factors to consider. First, the DNA profiles themselves contain a massive amount of deeply personal, sensitive information. Things about potential health risks, predispositions, other genetic traits, most of which is completely irrelevant to a criminal investigation.
Right, the police are looking for an identity, not someone's risk of Alzheimer's.
Exactly. Second, think about consumer intent. People upload their profiles to Ancestry DNA or 23andMe or GED Match because they want to find relatives or learn about their heritage or maybe get health insights. They didn't sign up to be part of a government dragnet, however well-intentioned. Their mindset is totally different from someone whose DNA is in CODIS because of an arrest or conviction.
That's a huge distinction.
It is. And third, the government itself has different responsibilities and restrictions compared to private citizens doing searches. When law enforcement wants to collect DNA either from distant relatives for comparison or from a suspect for confirmation, they have to operate within the bounds of the Fourth Amendment, protecting against unreasonable searches and seizures. The tricky part here is that FGG is so new, there isn't a lot of established law or clear precedent to guide how the Fourth Amendment applies in this specific context. The legal landscape is still catching up.
So what's being done now to try and balance investigation needs with these privacy rights?
Well, there are some measures. Agencies are generally expected to follow the terms of service of the genealogy companies they use. Some companies, for instance, flat out prohibit law enforcement use without a warrant. Others allow it, but only for specific, serious crimes like murder or sexual assault, and often require users to opt in to allowing their data to be searched by law enforcement.
Opt-in seems important.
Yes, transparency is key. Using companies that allow users to choose whether law enforcement can see their names if they come up as a potential relative is a big step. Though it's important to note, law enforcement typically doesn't get access to the raw genetic data itself, just the connection. There's also an ethical consideration to try and keep the names of innocent relatives, people just identified through the family tree building, out of official case reports where possible.
But is that enough? What are the risks if people feel their privacy isn't being respected?
That's the long-term worry. Eroding public trust. There was a case in Florida back in 2019 where a judge issued a warrant compelling GED Match to allow a search, essentially overriding the company's stricter privacy policy at the time.
Oof.
Yeah. If the public loses faith, if they feel these databases aren't secure or their data could be used in ways they never intended, you could see real consequences. Maybe stricter laws get passed that severely limit FGG, maybe even ban it, or maybe people just stop uploading their DNA. And if that happens, the tool itself becomes much less effective because the pool of potential relatives shrinks. It's a delicate balance.
Absolutely. So thinking bigger picture now.
Yeah.
What does all this mean for the future of forensics? FGG sounds like one piece, albeit a powerful one, in a much larger puzzle that's constantly evolving. What else is happening? What's next?
Oh, it's definitely part of a bigger wave. FGG is huge, but there are other really significant advancements changing forensic genetics. For example, there's something called massively parallel sequencing, or MPS. Think of it as next-generation sequencing applied to forensics. It lets labs analyze many, many genetic markers all at once. STRs, those Y chromosome markers, X chromosome markers, SNPs, all in one go. And it gives much more detailed information than older methods. Not just the length of a genetic sequence, but the actual sequence inside it. This is proving really powerful for complex relationship testing and criminal cases, especially with those degraded or minimal DNA samples we talked about.
More information from less DNA.
Exactly. Then you've got forensic DNA, phenotyping, FDP, and ancestry inference. This is pretty mind-blowing stuff. It's the ability to predict someone's physical traits like hair color, eye color, skin color, maybe even height, build, freckles. Sometimes even estimate their age using epigenetic markers called methylation patterns.
Wow, like a genetic eyewitness.
Sort of. And it can also infer their likely biogeographic ancestry, where in the world their ancestors came from. This is incredibly useful when investigators have no suspects, no database hits. It helps narrow down the possibilities.
That sounds like science fiction almost.
It's becoming reality. We're also getting much better at understanding DNA transfer or touch DNA left behind just by touching something. We're learning more about how factors like, whether someone is a good shedder of skin cells, what kind of surface was touched, how long ago, how all that affects recovery. Labs are constantly refining techniques to get usable profiles from tinier and tinier amounts.
So solving crimes from just a faint touch.
That's the goal. And finally, there's rapid DNA profiling. These are portable, automated systems that can generate a DNA profile in under 2 hours. Yeah, basically swab in, profile out. It's being used in active investigations for identifying victims quickly after disasters, even at border crossings sometimes. Looking ahead, specifically for FGG, the big needs are standardization across labs, better ways to interpret the complex data, and obviously more comprehensive databases balanced with privacy, of course. And beyond that, people are already exploring AI for things like haplotype reconstruction, maybe even roles for CRISPR gene editing technology and analysis someday, machine learning. It's a field that just doesn't stand still.
It really is incredible. It's clear this technology of GG and everything related to it offers just immense promise, but also these really significant ethical complexities. So as you're taking all this in, what should you, our listener, really take away from this deep dive? What are the key points?
I think the biggest takeaway, especially if you're in or around law enforcement, is the absolute need to use FGG, if effectively, yes, but also judiciously. That means working hand in glove with prosecutors and legal counsel right from the start of a potential FGG case. It means strict adherence to state laws, and critically, to the policies of the databases being used. No trying to find workarounds that could undermine trust.
Right, playing by the rules.
Absolutely. It also means choosing your partners, carefully working with reputable, accredited labs for the testing, and skilled ethical contractors for the genetic and traditional genealogy. Due diligence all around. And maybe the most important point to hammer home, forensic due diligence. Always, always conduct that independent confirmatory DNA test on a suspect. Always use traditional investigation to corroborate the lead and rule out other possibilities.
So just to reiterate that absolutely crucial point, the FGG result itself is never enough for an arrest, right? It's a lead, a powerful one, but not the whole story.
Exactly. It's an investigative lead, not a verdict. Forensic genetic genealogy is undeniably a powerful tool for solving cold cases, identifying victims, finding missing persons. It lets us get answers from DNA that were impossible just a few years ago. But law enforcement must use it effectively and judiciously. They have to maintain that public trust or risk losing access to this valuable method. We've seen examples, like in Brazil, where a large database helped investigations. But even there, a hit is just the start. It always requires solid police work to follow through.
What a journey through this incredible, complex technology. Our goal with this deep dive really was to help you understand this rapidly changing landscape, to give you the essentials so you feel informed without getting totally overwhelmed. Now, as you think about all these advancements, but also the complexities, here's something to ponder. What are the long-term societal implications if the sheer convenience, the power of a tool like this, starts to overshadow the fundamental right to privacy, not just for criminals, but for everyone connected in this vast genetic web? Where do you draw the line?
Thanks so much for listening, everyone. If you enjoyed today's episode, please like, share, and subscribe. It really helps us out. Until next time, take care and keep your chores company.